Hi guys, I hope you all are doing good. So we will continue with the DSA sheet backtracking. I think 2 or 3 more problems are there. So let us quickly try to finish it. These questions are a little hard, and the implementation is actually hard part because solution anybody can think about it, but how to implement is quite challenging at times. Okay. So the problem is remove invalid parentheses. So it is actually hard problem, but logic is quite simple. I'll simplify it for you, don't worry. So please pause the video and read the problem by yourself once. Okay, so given a string that contains parentheses and letters, remove minimum number of invalid parentheses to make input string valid. Return all possible results. You may return in any order. So what is a valid string? So here the question says we need to find all valid strings. Valid string means all the parentheses are balanced. So we have to return all those possible combinations which have balanced parentheses. For example, if we consider the string to be this, here if you observe, this is not completely balanced because for this outer bracket there is no, sorry, for this closing bracket there is no opening bracket. So this is not balanced. So what you can do, you can actually either you remove this character, okay, and you will get this string. So this is a balanced string here because see, opening bracket has a closing bracket. Same thing happens for all the opening brackets. Or you can do one more thing, that is you can, so you're given this string, right? Instead of removing this character, we'll remove this character. So what happens if we do that? We will get this string. See, both of them are balanced because opening, so two opening bracket and then closing, two closing bracket. So they are matching. So it is balanced. So all the parentheses are balanced. So these parentheses kind of problems we have already seen in stack. That is longest valid parenthesis, balanced parenthesis. All these are stack problems, right? So let us just revise that. How we can use stack to determine how many number of removals are needed. That is, how many parentheses you should remove to make this string balanced. How do we do that? So let us take a stack, okay, of character type. Let us traverse this string. Whenever we find opening bracket, so if s of I is equal to opening bracket, then just push it in the stack. All right. Else, if s of I is equal to closing bracket, now what should we do? If it is a closing bracket, we should check if the top of the stack. So we should check first of all stack is not empty. Right, we should check stack is not empty, as well as if top of the stack is equal to closing bracket, then we'll pop that closing bracket. Otherwise, what we'll do? Otherwise, we'll add it. We'll add this character also to the stack. So what happens is, I will show you, see this is a stack. Okay, so we are starting from here. We'll traverse through this string. We have an opening bracket, put it in the stack. Then we get a closing bracket. When we get a closing bracket, check the top. First of all, check stack size is not empty. Yes, not empty. Check the top. Yeah, top is opening bracket. So remove it. Fine. Now come here, again opening bracket. Then here closing bracket. So remove this opening bracket. Then closing bracket we get. Now see the stack is empty. So stack size not equal to 0, this condition is false. So it will go here. It will push this element. So now it has a closing bracket. Now opening bracket we get. So we'll put opening bracket also. Then we get closing bracket. So we'll remove the opening bracket. So ultimately, what is the stack? Stack is this. And size of stack is what? 1. It means that we have to remove one parenthesis to make the entire string balanced. We have to remove how many? One parenthesis. So size of the stack will give us number of removals. But which parenthesis should be removed? That is the actual problem. So see, in this example, only one we have to remove, right? But we can have other examples wherein we have to do multiple removals. So we need to remove different parentheses from the string and check which are the balanced ones. That means, see, I'll erase all this now. Once I'll show you again. 1 second. Right. So we, what did we get? We got size of the stack. We got stack size as 1. It means we have to make one removal. We have to make one removal to make this balanced. But before I discussed how can we make the one removal, either we remove this parenthesis or this. That is, we get this string or we get this string. Both of them are valid. Okay, so although we have to make one removal, we have to see which one to remove. So this is brute force problem only. This is brute force, and we have to check all possible combinations of the string. What do I mean check all possible combination? We need to remove those characters. We need to remove those parentheses and check. See, what do I mean remove? Suppose I consider this, okay, this parenthesis here. I want to remove this. When I say remove that, it means what is the left side, what is the left part of the string? This. The left side of this is this string only, na? And what is the right side? Right side is this. So when I say remove, I will join left side and right side of the current index and make it a new string. All right. And I'll apply the same algorithm again. But this time, the number of removals I make will be -1 because I have removed one. See, I removed this. How I removed? I joined the left part and right part, which is excluding this character. It means that I'm removing this character. And I'm going to recursively find the answer for this new string. See, this new string recursively I'm finding. But number of removals I have made is now -1. Removals -1. One less because I have removed one now. Na? Like that, how many ever removals we make, when that removals will reach 0, we need to make some number of removals. When that removals will become 0, again we have to check if the string is balanced or not. For example, see, in this case I have to make one removal, correct? Suppose I consider the first index only and I say that, okay, I'll remove this. What is left side of the first index? Nothing. Right side of the first index is this string. So if you join these two, ultimately it is this only. Fine. Now how many removals are needed for this? Totally we needed one removal. We already did that. So our removals has now become how much? 0. Does that mean this is the answer? No. We have to find out whether the total number of removals for this string is actually 0 or not. That is, we have to take the help of stack again. All right. And we have to perform the same operation, that is push the opening bracket, and with the closing bracket we have to do pop, like that. The operation that we did to get this value, the same thing we have to do. And this time if we do the same thing here, we should get the size of the stack as 0, because if it is completely balanced, then the size of the stack will be 0, and if it is balanced, then we will add it to our answer. We have vector of strings. We have to ultimately return what? We have to return vector of strings, right? So we'll add it to our answer there if this is balanced. So each and every combination we have to take and check after doing those many removals, are we getting a balanced string or not? And balanced string means, see, balanced string, just when you get confused, now just say balanced string means parentheses are balanced. It means that you can have characters also in between. See, in the second example here, in Leetcode, second example, there is a character A. We are not bothered about the character A. It should be in a balanced parenthesis only. See, this example, they are saying output can be this. The parentheses and all are balanced, right? For every closing bracket, there will eventually be an opening bracket. See this example carefully. Same way here also, for every closing bracket, there will be an opening bracket. So this problem is not depending upon characters. It only depends on our parentheses. So if our parentheses are balanced, it means if size of stack is 0, then it is completely balanced. So when we are trying to do this, then to optimize this approach, what we can do is, if we have already found a combination before, if you have already found a combination, like for example, I'll show you what I'm trying to say. Okay, so this was the string. Now consider that I am going to remove this character. If I remove this character parenthesis, what is the new string? The new string I am going to get is, see, this is the left side of the string and this is the right side of the string, correct? Now I join left and right, excluding that character. I am going to get this string, correct? So I got this string after I removed this character. Suppose now consider the same input string. Instead of removing this, I'll remove this character. So instead of removing this character, I'm going to remove this character. Okay. Next index. What is the string going to be now? Same thing. So whatever answer we find for this string, that is, if we have already operated on this string, we don't have to do it on this string again. So we can keep a map actually. We can keep map like this, string and bool. It means we have already seen the string. So if map of our string is true, then we will return. We won't do anything in that function. We have already processed that string. We have already operated on it. We don't have to do anything else. We already know the answer for that. All right. We know the answer. It can either be yes or no, that we already have done. So once we have found, we don't have to find for the other. So this is optimization part. So optimization, same like memoization type of thing. Recursion memoization is optimization, right? Same thing, just with the help of map here. So all the possible combinations we have to do. And in this example, only one removal we have to do. But there can be multiple removals. So if we have to do 2, 3 removals, we have to remove a set of characters, and all those combinations left after removing, we have to check if that is balanced or not. It means consider the number of removals required was 2. That is, to balance this string, consider that we needed 2 removals. Instead of 1, we needed 2 removals. Okay. So then what we have to do, see, first time we'll remove this, we will get this character. Then we can either remove this or this or this or this or this. We can remove either one of them. All the possible combinations that are left, that we have to evaluate whether it is balanced or not. So now I think you have some idea at least. So I think I can show you the code. See here, I am taking an unordered map. So basically this is the function that is given to us. We are given input string only. Okay. I am taking unordered map here. And I'll first find out what is the minimum number of removals needed to get a balanced string. To balance all the parentheses, what is minimal removals? So for that, I am writing a function find removals. I'll show you that function. So find removals, I'm passing the string here. Okay. Then I'm taking vector of strings to store my answer. So I'm taking a container vector of string and I'm passing all this to solve function. I'm returning the answer here. So what is this find removals function? See here, find removals, basically it will tell me how many minimum number of removals are needed to balance the parenthesis, to get balanced string. So take a stack, traverse through the string. If you get a opening parenthesis, push it in the stack. If it is closing parenthesis, then check if stack is not empty and top of stack is opening parenthesis, pop it out. Otherwise, push closing parenthesis also in stack. Ultimately, whatever is the size of the stack at the end, that only will be our minimum number of removals. So this stack method is actually used to find that only minimum number of removals. All right. Notice that we are not depending on the characters, although the string can contain letters also. We only depend on our parentheses, not our letters or other characters. Okay. And now most important is what is the solve function. So solve function, it will take string, vector of string, it is passed reference, and this map for optimization part, and number of removals required. So basically, for now you forget all this, okay? Just concentrate on this part. See, we are iterating through the string and we are calculating what is the left side of the string, what is the left substring of our current character, what is the right substring of our current character, and we are going to join the left and right. It means that our current character we have eliminated. We are not including that in our new string. That means we have removed that character. We have made one removal. So now recursively, I'll again find the answer for this new string. So I'm passing join here. And see, removals -1 I am doing. All right. Now, what is the use of this map here? This map here will tell me whether I have processed a string already or not. So if map of S is already true, then I don't have to compute it again. I've already got answer for that. Either it can be yes or no. So I'll just return. I won't do anything. If this condition is false, I'll say map of S is true. Okay, that means I'm going to process the current string. Then I will check if our removals has become 0. That means after doing some number of removals, finally we have got a combination of characters. We have got a subsequence basically. And now we have to check in that subsequence if it is balanced or not. We have to check if balanced or not. So I'm saying removals needed. I'm going to find out how many removals are needed for my subsequence. So I'm passing this function again. Sorry, I'm passing the string to this function again, find removals. Now, if removals needed is 0, that means it is a balanced string because now I have, see, now I am assured. See, this is assurance part. This, whatever we are doing now, we have to assure that, okay, actually it is balanced. So if it is actually balanced, we'll put it in the answer. Okay, we'll put it in the answer. And either way, if it is balanced or not balanced, because our removals has become 0, we have removed some number of characters and now we can't remove more. It won't make any point of removing more. We'll return. All right. So this is assurance part. First, our removals should become 0. Then we should check if it is actually balanced or not. So I'll write here, checking for valid answer. So it is actually going to check if it is balanced or not. How? If removals needed now is actually 0, it means then it is balanced. So I already submitted, actually you can see it is giving correct answer, success here. You can submit once again. So this is the problem. We have made use of stack, backtracking, map, memoization, all those kind of concepts. So this is hard problem simplified. I hope you were able to solve it, and at least now you are able to solve it. All right. So if you like the explanation, please hit the like button. Share the video with all your friends as much as possible. Subscribe to the channel. We have reached 4,000 subscribers. Thanks a lot for that. It is really motivating. All right. And until the next video, take care, stay safe, keep learning, keep growing, stay tuned. Bye.